Hello!
Hello, hello! Welcome back from intermission. Hope you all had a good one. My name is Sinclaire Manning, also known as Major Merger.
I am Brian Mulligan, also known as Astrobits.
And we are here to give you this month's top news stories in astronomy. Yeah, woo!
Other way.
We're all having clicker issues tonight.
There we go.
There
Okay.
we go.
All right. So first off, first of all, this headline is already out of date.
As of 6 hours ago or something?
Something like 6 hours ago. All right, so there was a lot of news about space telescopes this last month. The Hubble Space Telescope and Chandra X-ray Observatory both experienced failures. Kepler also experienced a failure. Some of them are already back online to one degree or another. So on October 5th, one of the gyroscopes of Hubble Space Telescope failed. A backup that was supposed to come in and take its place was behaving erratically, so Hubble is now temporarily shut down. Hubble has 6 gyroscopes in total. 2 had previously failed, so that this third one takes it down to 3. 3 is how many it needs to operate. With the one that's behaving strangely, it means there's only 2 available. It can still operate with just 1. They're trying to get this one that's working a little bit weird up and going again so that they can get back to normal operations with 3. If it goes down to 1, Hubble's field of view, I don't exactly know how this works, somehow it can't look at as much of the sky as it otherwise could, so it reduces the effectiveness of Hubble. So they're hoping to get back to 3. If they can't get the third one working, they've got 2, they'll switch down to 1 and then keep the other one as a backup. Hubble's expected to last, even with this recent failure, at least for into the 2020s. Then, on October 10th, Chandra X-ray Observatory experienced a glitch, resulting in it going into safe mode. After analysis, this also turned out to be a gyroscope problem. Fortunately, Chandra has a backup gyroscope that it's able to work on. It was brought online yesterday, and Chandra is now back up to normal operations. Yay!
Damn
One's working.
gyroscopes.
Chandra X-ray Observatory, a little background, is used to image the sky in X-rays, look at high-energy phenomena such as black holes, neutron stars, and quasars. It was launched by Space Shuttle Columbia, one of the last few missions of Columbia in 1999. It was originally planned as a 5-year mission. 20 years on, it's still going and expected to continue for several more years. And then finally, Kepler Space Observatory was put in hibernation mode on October 1st due to problems with a system that keeps it oriented. It was reawakened on October 12th and oriented itself to Earth on that day to start transmitting the data from its last observation mission. Efforts are still ongoing to diagnose a problem with one of the thrusters on board. The mission team hopes to find a solution that will allow the telescope to return to normal operations. The observatory is used to identify planets that or exoplanets that we've been talking about a lot tonight. So far, it's found over 2,600 exoplanets with another 2,700 candidates. It was launched in 2009. It experienced failures of its reaction wheels, which were originally meant to keep it oriented, in 2012 and 2013. After that, it started a new mission now called K2 in 2014 that's able to use the spacecraft without the reaction wheels, but they need their thrusters to keep it pointed all the time, which is why this recent thruster problem is causing problems for it. Hopefully it keeps going for at least a few more years.
Kepler just can't catch a break.
No. It's
always something with that one.
It is not one that's going to last 30 years.
Space telescopes.
Okay. Yep, I hit the right direction this time.
Okay, so the hunt for Planet 9 continues. If you don't know, Planet 9, also known as Planet X, is a hypothesized and highly debated planet thought to be roughly the size of Neptune and exist in the Kuiper Belt in the outer solar system. However, it is yet to be located or imaged, which is very mysterious and spooky and good for the month of October, I guess. But in one of my new favorite planet names, we have found
also good for October.
Also good for October. We have the Goblin. So someone asked before what was the name of a planet, and it was a really boring collection of letters and numbers, but this has a great name. So 2015 TG387, which is the official name, but also known as the Goblin, is yet another clue in the search for Planet 9, as it shares certain peculiarities exhibited in other solar system objects, which appear to have been shaped by the gravity of a very large object located in the outer solar system, or this Planet 9. So Scott Shepard from the Carnegie Institution for Science in Washington, D.C. says the Goblin and other distant objects they've discovered are like breadcrumbs leading us to Planet 9. The more we can find, the better we can understand the outer solar system and the possible planet that is shaping these orbits. So it took researchers 3 years to nail down the Goblin's orbit using observations from the Subaru telescope in Mauna Kea in Hawaii, as well as the Las Campanas Observatory in Chile and the Discovery Channel telescope in Arizona. So the Goblin loops around the sun in an extremely elliptical path, coming within 63 AU of the sun and as far away as 2300 AU. And an AU, or an astronomical unit, 1 AU is equivalent to 93 million miles. So 63 and 2300 times 93 million miles is a lot of miles. So all of this means that it takes about 40,000 years for the Goblin to complete one orbit around the sun. So good luck having a birthday on the Goblin. But Shepard puts the odds of Planet 9's existence at about 85%, but says it's not surprising at all that astronomers haven't spotted it yet, considering how faint it is despite its size. And it turns out you can hide a very big thing in the outer solar system very easily.
Okay, back more in the inner solar system, the Japanese spacecraft Hayabusa II, somebody else might not be able to pronounce that better than I can. Is that right?
Got that right. That's right.
Oh, wow.
Well done. Points for Brian.
So it deployed 2 different landers onto the asteroid Ryugu. Yay.
Killing it.
All right. So on September 21st, Minerva 2 landed on the asteroid and deployed 2 small rovers, creatively named Rover 1A and Rover 1B. Those rovers carry cameras and thermometers, but they're able to hop short distances along the surface of the asteroid and keep taking pictures and temperature measurements. They use solar power, so those can continue to operate for some time. There's another rover coming out of Minerva called Rover 2 that will be deployed sometime next year. There's another lander that also landed this month called Mascot, so it touched down on October 3rd. That contains a spectrometer, magnetometer, radiometer, as well as a camera, but it was only powered by a battery and lasted 16 hours. So not very long, but it got some really good data in those 16 hours. Hayabusa 2 is also going to collect a sample of the asteroid and return that to Earth. It's expected to reach Earth in 2020, so stay tuned.
We already talked about the Goblin.
You don't want to talk about it again?
No. All right, so the recently published data from the second data release of the Gaia spacecraft mission has offered up a new explanation for the high speeds obtained by some stars. The Gaia spacecraft was launched in 2013 and has since provided extremely accurate position measurements for 1.7 billion stars, enabling astronomers to better understand the very fast stars known as hypervelocity stars. So researchers have believed the black hole at the center of the Milky Way is responsible for flinging out these stars at these high velocities. They thought the stars originated from the center of the galaxy and that the gravitational interaction with the black hole caused their high-speed journey and possible escape even from the Milky Way. So of these 7 million stars that have full 3D velocity measurements from Gaia, Dr. Elena Maria Rossi, shown here on the right, and collaborators found that 20 of them could be traveling fast enough to eventually escape the Milky Way. But the other possibility is that these are intergalactic interlopers. So rather than flying away from the galactic center, which are the points marked in red with the arrows, most of the hypervelocity stars found are actually racing towards the galactic center, which are shown in yellow. So these could be stars from another galaxy or a nearby neighbor, like the Large and Small Magellanic Clouds. And the presence of these stars might be indicators of black holes in nearby galaxies, or they could have once been part of a binary system and ejected out after their companion star exploded as a supernova.
Woo!
As some people enjoy that scenario a lot more. But at least 2 more Gaia data releases are scheduled again for the 2020s, so stick around for the 2020s. They're going to be really exciting times, and which will continue to aid our understanding of the origins of hypervelocity stars.
All right. An unusually low-mass supernova was reported this last month by Kishalay Day, a grad student at Caltech. So he was looking at data on supernova, this is one of our really good names, IPTF 14GQR. It was observed, go ahead.
Classic.
Yeah. It was observed in 2014 and had an unusually small amount of material ejected. So massive stars need to be at least 8 times the mass of our sun in order to explode. Typically, about 2 solar masses is held up in the neutron star, or maybe a couple times that in the black hole that's formed. This one, however, and the rest of it gets ejected. So, something like 6 solar masses ejected in a supernova. This particular one was observed to eject only 2/10 of a solar mass of material when it exploded. So the belief is that what happened in this case is that the star had a companion that gobbled up those other 6 or 7 or 8 or 10 solar masses of material from it before it managed to explode. It left just enough behind for the core to reach the critical stage that caused it to collapse and go into explosion. Such events have been theorized in the past. This is the first time we've ever actually seen one of these explosions with such a low mass of material that kind of confirms the theory that these might exist. Very exciting.
Last up, astronomy not in the news. So this is a news story that maybe didn't get all the attention it deserved in the internet or wherever you get your news from.
The inner tubes.
The inner tubes.
Information superhighway.
So last year, thanks to some amazing multi-messenger observations that were definitely in the news, we learned about the power of neutron star mergers. So they are a source of gravitational waves, electromagnetic radiation, and neutrinos. And on top of all that, astronomers were able to confirm that neutron star mergers are a site where heavy elements, so those heavier than iron, can be produced via what's known as the R process. So while this observation was super cool, a lot of work remains to be done. So researchers have been working to model these merger scenarios to predict the quantity and composition of the material ejected from these violent episodes in order to fully understand the origin of heavy elements. Now, Dr. David Radice and collaborators have released the largest set of neutron star merger simulations with realistic microphysics, meaning they've taken into account the physical processes that occur on atomic and subatomic levels. So they carry out 59 high-resolution numerical relativity simulations using these neutron star binaries with different total masses and mass ratios. So the plot on the left shows what one of these simulations looks like for a merger where both neutron stars are 1.35 times the mass of the sun. And the radioactive decay of the heavy elements produced by the merger give off electromagnetic radiation, referred to as a kilonova. Yes, I need his. And on the right, the plot shows these kilonova curves for different models. So on the y-axis is the brightness of what you're seeing, and the x-axis is the time in days, and the different colors of curves correspond to the different wavelengths of light that you're looking at. So the models are predicting that mergers, and then the one on the left is a merger that results in the immediate creation of a black hole, and the one on the right is a hypermassive neutron star that forms. So you have 2 colliding together and then create one bigger neutron star. So the models are predicting that mergers that form a black hole produce fainter electromagnetic signals for a shorter amount of time compared to when the remnants are longer-lived neutron stars. So astronomers will look to further constrain these models with hopefully future neutron star merger observations, as well as an improved understanding of nuclear theory.
Cool.
Yeah.
Very cool.
And with that,
All right.
that is all we have for you this month.
Well, thank
Astronomy
you.
in the news. Thank you.
So enjoy the rest of the show.